Okay, so welcome everyone. So today, this topic for system design, wherein we again go into one of the very basic and common example or use case, you can say, is uploading photos, right? So you can have a system design interview question wherein this is a very common thing where you need to play around with, okay, uploading photos, images. So if you have situation like this in your system design, you have a requirement to upload photos. These are some very common, I would say, steps or some of the common thing which can be generalized. I'm sharing with this video that you can learn, you can use it, you can put it in all system design problems where there's images are involved, uploading of images is involved. I will try to cover is with this particular video is like what should be the strategy whenever you have this particular thing, photos and uploading concept in a system design problem. What should be the strategy, what you should ask for from an interview first, and then how can you should play around numbers for the data estimates, storage estimates, and things like that. So yeah, on this series, I'll be covering more examples, and then in my other videos, which you have seen previously, I already covered a very good cheat sheet example that you can see the link on the top. So this cheat sheet is very detailed, common things which you can learn or memorize, and you can use it in all the system design problems, no matter what the topic is. All the system design problems you can generalize or you can use those things. Coming to this problem, uploading photos on social media, let's go and dig into this question. So let's say the interviewer asks, estimate the storage around required for 1 million users uploading 10 photos each. So let's say there are 1 million users, and each of those users, they're uploading 10 photos, right? So one photo is, let's say, 2 MB of size. Let's say that is something which interviewer is saying you, and then it says every day for a year. So you have to find the estimation for the storage requirement for 1 million users who are uploading 10 photos each of size 2 MB every day for a year. So looks like a bigger problem, right? But again, any bigger problem is going to be smaller and simpler when you split it into different parts, different data points, right? So let's go and dig into those points. Clarify requirement. So you must ask first, what is the retention period for the data that we are targeting? So for example, let's say we create something for 1 day, then for 1 day, and then you just calculate it for 1 day data requirement. Then you need to also understand for how long you're going to retain that data, because that number of days, that retention period is going to be a very crucial factor for deciding the total storage you need, right? So one of the clarify requirement is retention period, average photo size, which I think you already got, which is 2 MB, that you can discuss with the interviewer. And then, as I said, you have to have one unit uh, execution for your question. So here I will try to find out data requirement for 1 day for this particular problem where we are using uploading photos. Okay, so data requirement per day. So now daily data is that 1 million users every day. So 1 million, 160s, right? Multiplied by 10 into 2 MB. So over here, if you see this 10 photos each, right? So 1 million users and 10 photos each. So 1 million multiplied by 10. And then each photo size is 2 MB. You multiplied by 2 MB. Focus on this. This is 2 MB. So this will be around 20 million MBs. Now, again, remember my three zeros strategy? Yes. So these three zeros with MB will turn into 20,000 GB, because these three zeros MB means 1000 MB will be GB, and then 20,000 GB. So again, these three zeros will be TBs. So 20 TB. So 20 TB is the daily data target storage requirement. Meaning, if 1 million users who are uploading 10 images for next for each of size 2 MB, we would need 20 terabyte of data requirement every day. Now, It depends now on the retention period, which is the crucial factor here. So let's say the retention period is 1 year. Okay. So how much data do we need now? So 1 year is 365 days. So because this 20 TB is for 1 day, so you will do 20 TB multiplied by times by 365. So 365 multiplied by 20. Again, do not go and do the, maths, like very core maths, what exactly that number would be. You can just turn this 365 to roughly 400, right? And then 400 multiplied by 2 is like 20, so it would be uh, 800, and then 0 is here, so 80, 8,000 is something which you're getting roughly, right? So 8,000, again you're getting three zeros, right? So three zeros and you have terabyte, so now it will be petabyte. So over here you see 7.3 petabytes. So that is the reason why you can have, roughly around 8 petabytes or 7.3 petabytes. You could also do this as, like, instead of 365 to 400 approximation, you can say it's like 365 to 360. So 36 times 2 is 72. So it will be around 7.2 petabytes. Uh, Now, again, these are the photos. Always remember, when you talk about text, when you talk about photos, anything like that, or videos, you must clarify upfront in order to save your data storage. Can we do optimizations in compression? Yes. Let's say it is an agreement. We can do optimization 0.5%, 50%. So if when we say 50%, we are saying here 0.5 of 7.2 or petabyte, 7.3 petabyte. So it will be coming around 3.65 petabyte of data. So this was the problem, which was a bigger problem. How much data do we need for 1 million users who are active every day and uploading 10 photos, each of size 2 MB every day for a year? Simple. It will be 3.65 terabyte of data. So you should memorize all these things. Why am I actually sharing all those examples with you? That once I give you 5 6 examples and calculations of these numbers, you will be much more confident in coming with any data estimations for any problem statement you have. Videos, images, photos, logs, whatever it is, right? So we need 7.3 petabyte uncompressed or 3.65 compressed for storing a year's worth of photos. That is the final answer. Thank you very much. I see you in another video.